Welcome back to the Math Revision Made Meticulous video series. Today topic 3-dimensional geometry. Straight line in space. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us go to question number 1, which has come from CBSE 2018 question paper. Find a point on the line x plus 2 upon 3 equal y plus 1 upon 2 equal to z minus 3 by 2 at a distance of 3 root 2 from the point 1, 2, 3. We have to get a point on this line which is at a distance of 3 root 2 from another point. Therefore, this is the given line. Now, whenever you want to have a point on that, we will just go for a general point. It is obtained by equating the symmetric form to lambda. Remember, it should be done after the given straight line is converted into standard form. Here it is in the standard form. Which is the standard form? The coefficient of x, y, z will be 1 in the numerator. That is the standard form. Well, it is equated to lambda. X plus 2 by 3 is equal to lambda is x is equal to 3 lambda minus 2. Similarly, y plus 1 by 2 is equal to lambda implies y is equal to 2 lambda minus 1. Similarly, z is equal to 2 lambda plus 3. Now, in most of the 3-dimensional problem, whenever we take the coordinate of any general point, we will call it as a point which we require. Therefore, let the required point which we want is this 3 lambda minus 2, 2 lambda minus 1 and 2 lambda plus 3. Now, what it is given? It is given the distance of this 3 lambda, this whatever the point which you have taken from the point 1, 2, 3 is 3 root 2. It is given at a distance of 3 root 2 from the point. Therefore, we will use the distance formula. x1 minus x to the whole square plus y1 minus y to the whole square plus z1 minus z2 to the whole square inside square root. I have squared both sides, so that square it will go. We will expand it, and when you expand it, it will become 9 lambda square minus 18 lambda plus 9 plus 4 lambda square minus 12 lambda plus 9 plus 4 lambda square is equal to 18. If you are doing the simplification, lambda you are getting it as 30 upon 17. Now the point which we require is made up of lambda. Put the value of lambda there, do the simplification, you will get the required point as 56 by 17, 43 by 17 and 111 by 17. Here what we have done, we have taken a general point and we have used the distance formula to eliminate that general point. Well, now already we have seen angle between two lines. If theta is the angle between the lines, this is given in terms of symmetric form only, which cos theta is being done with the direction ratios a1 a2 plus b1 b2 plus c1 c2 upon square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Now if the lines are parallel, all of us know that the direction ratios are proportional. If they are perpendicular, then the product of the sum of the product of the direction ratios is equal to 0. Using this, so many problems we have already seen, eliminating lambda when two lines are given as perpendicular. Let us go to one more problem in CBSE 2020 question paper where find the vector equation of the line. Please be careful, they want the vector equation of the line which is perpendicular to the lines. Two lines are given, it is perpendicular to both the lines and passes through the point. And one more question is asked, also find the angle between the given lines. Remember, the question is asked in vector form. Well, let us now take these two lines. These lines are given. And the direction ratios are which are in the denominator. Remember, these direction ratios are to be considered after converting the given equation into symmetric form, that is standard form. Now let us take the equation of the required line. It is passing through 1, 1, 1. Therefore, it will become x minus 1 by a, y minus 1 by b, z minus 1 by c, where the numbers in the denominator are direction ratios. Now this line which I have considered is perpendicular to the two lines which are given. Now I have already shown you the direction ratios in a different color, so that we will get two equations making use of the perpendicularity idea, that is sum of the product of the direction ratios is equal to 0. For the first one, a into 1 plus 2 into b plus 4 into c is equal to 0. Second equation, once again from the second line, 2 into a plus 3 into b plus 4 into c is equal to 0. We are multiplying the corresponding direction ratios of the lines which are perpendicular and equating it to 0. Now these two equations are homogeneous. homogeneous equations where the right hand side is 0. Now we are going to make use of the cross multiplication method to solve it. For that, you write the coefficients one after the other. Start with the coefficient of b, coefficient of c, coefficient of a and coefficient of b from the first equation. Again coefficient of b, coefficient of c, coefficient of a and coefficient of b from the second equation. Now you are having two rows of numbers, 4 numbers each. Now when you take the first two column, you can get the value of a. To get the value of b, you have to take the next two column. To get the value of c, you have to get the next two column. How to get the value of a, b, c? All of them will be proportional to a upon, take the first two column and put it as a 2 cross 2 determinant, b upon, make the next two, put it as a 2 cross 2 determinant, and c upon next two, put it as a 2 cross 2 determinant. We are making use of cross multiplication method. Now cross multiply it, it will become a upon 8 minus 12, b upon 8 minus 4, c upon 3 minus 4, for a upon minus 4, b upon 4 and c upon minus 1. For this minus 4, 4 and minus 1, they are proportional to a, b, c, therefore they are the direction ratios. For minus 4, 4 and minus 1 are direction ratios. Now we want the equation of a line passing through 1, 1, 1. We got that point, we got the direction ratio. Put it in the form now, x minus 1 by minus 4, y minus 1 by 4 and z minus 1 by minus 1. Here what we have done? We have used the idea that the given line, the required line is perpendicular to two given line, and we have found the value of ABC using cross multiplication method. Now question is not over. They want the angle between the lines. The two lines are given. Their direction ratios are 1 to 4 and 2, 3, 4, and we are using the cos theta formula. Therefore the answer is 24 upon root 609 is cos theta. Therefore theta is cos inverse of 24 by root 609. And these two lines are perpendicular to the line which you have already found now, but they are simply want the angle between the two given lines only. Well, let us go to the next idea, foot of the perpendicular. What is the meaning of foot of the perpendicular? From a point you are drawing a perpendicular, it meets the line at a point, and here in this diagram for p, q is the foot of the perpendicular. Now in the exam they will ask you find the coordinate of the foot of the perpendicular. How to do it? Express the given equation in standard form. That is, I am talking about Cartesian. Then obtain a general point. You know how to get a general point? Equate it to lambda. Then assume this general point as q. Any point on that line is this, therefore we will call it as q. Then after that, obtain the direction ratios of pq. How to get it? x2 minus x1, y2 minus y1, z2 minus z1. Already we have discussed. When the coordinate of 2 points are known, how to get the direction ratios. Then now only we are having that lambda. How to eliminate that lambda? We have to make use of the condition once again, that what is the condition for perpendicularity? Sum of the product of the direction ratios is equal to 0. Then simply substitute lambda to get the required foot of the perpendicular. Remember how to get the foot of the perpendicular? Step number 1, express the given equation in standard form, get a general point, assume this general point as the foot of the perpendicular, then obtain the direction ratios of that perpendicular, that is PQ. Then eliminate lambda using the condition that this PQ is perpendicular to the given line. That is, you are having the direction ratios of both the PQ and the given line. For make use of the condition for perpendicularity and eliminate lambda. Let us go to question now. Find the equation of the line passing through the point. If D is the foot of the perpendicular drawn from the point C on the line AB, then find the coordinate of the point D and the equation of the line CD. So many questions have been asked in 2010. Let us see. This is the Cartesian equation, always we know, where we will take the first point 0, 6 and minus 9, and we will construct the equation x minus 0 by the x2 minus x1 is minus 3 minus 0, y minus 6 upon minus 6 minus 6, then z minus of minus 9 by 3 minus of minus 9. Well, this is the equation, x upon minus 3, y minus 6 by minus 12 is equal to z plus 9 by 12. Remember, even if for foot of the particular problem, if the problem is given in vector form also, we have to make use of it. Well, therefore this simply gives you x upon 1 is equal to y minus 6 upon 4 is equal to z plus 9 by minus 4, because you can simplify it, because they are all direction ratios. You can divide the whole all the direction ratios by minus 3, it will become 1, 4 and minus 4. Good. Therefore we got this equation now. We are assuming that D is the foot of the perpendicular. Step number 1, get a general point on it, equate it to lambda. X by 1 to lambda gives you lambda minus 0. Y minus 6 by 4 is equal to lambda gives you 4 lambda plus 6, and the third one will give you minus 4 lambda minus 9. Well, let this be capital D. Now get the direction ratios of CD now. You have 7, 4, minus 1 and this D. Subtract it now. Lambda minus 7, 4 lambda plus 6 minus 4, minus 4 lambda minus 9 minus or minus 1 will give you lambda minus 7, 4 lambda plus 2 and minus 4 lambda minus 8. Do it carefully, the simplification. Now we got the direction ratios of CD and we have the direction ratios of the given line. These two lines are perpendicular. What is the condition for perpendicularity? 1 into lambda minus 7 plus 4 into 4 lambda plus 2 minus 4 into minus 4 lambda minus 8 is equal to 0. Collect all lambda and then collect all the constants. You will get lambda is equal to minus 1. Now you got the coordinate of D as lambda, 4 lambda plus 6 minus 4 lambda minus 9. When I put lambda is equal to minus 1, the coordinate of the foot of the perpendicular is minus 1, 2 and minus 5. Now apart from that, they want the equation of that CD. How to get the equation of the CD? You have the direction ratios now, 8 to 4, which can be written as 4, 1, 2. Then the equation, you can take any point. Either you take 7, 4, minus 1 or 4, minus 1, 2, minus 5, and you can write the equation as x minus 7 by 4, y minus 4 by 1, z plus 1 by 2. In the exam, they may ask you equation of CD. Otherwise, they may ask you the length of the CD. Anything they can ask. If they ask the length of the CD, all of you know, you can use the distance formula and you get the CD. Now let's go to the next idea called image. Image is a extension of foot of the perpendicular. If Q is the image of the point in the given line, then PQ is perpendicular and M will be the midpoint which lies on the line. Therefore, two things are there. One is PQ is perpendicular to the given line. That is the line joining the point and its image is perpendicular to the given line. And the midpoint of the line joining P and Q will lie on the line. These two things, that will be the midpoint. The midpoint will be on PQ. Now how to get it? Express the given line in standard form. Let Q be the image. Alpha, beta, gamma I will call. Then I will call a general point on this given line. I will call it as capital M. And now the foot of the perpendicular getting, already we know how to get it. Direction ratios of PM you get. Eliminate lambda using the condition that PM is perpendicular to the given line. After getting the lambda, get the midpoint M. Then again use the midpoint formula to get the coordinate of the image. But here, after getting the foot of the perpendicular, we are going one step further to get the image. That's all. Therefore, this image problem is an extension of foot of the perpendicular. This is a question from 2010 question paper. Find the image of the point on the line. Also write the equation of the line joining the given point and the image. And find the length of the line segment joining the given point and the image. Three questions are there. Let us see one after the other. Now alpha, beta, gamma I am calling as the image. Let M be the midpoint. Now we say I am showing the figure. M is the midpoint. And the coordinate of any general point on the given line is, by equating it to lambda, already we have done it. It will become lambda minus 0, 2 lambda plus 1, 3 lambda plus 2. Now we call it as capital M. Now we call it as capital M now. This capital M is lambda, 2 lambda plus 1 and 3 lambda plus 2. I can find the direction ratios of PM now by subtracting now lambda minus 1, then 2 lambda plus 1 minus 6, then 3 lambda plus 2 minus 3. It will become lambda minus 1, 2 lambda minus 5 and 3 lambda minus 1. Now what is the direction ratios of the given line? It is 1 is to 2 is to 3. Now we have to multiply and equate it to 0. 1 into lambda minus 1, 2 into 2 lambda minus 5 plus 3 into 3 lambda minus 1 is equal to 0. I am eliminating lambda, I am getting lambda is equal to 1. If I get lambda is equal to 1, very quickly I can find the coordinate of M. It is 1, 2 into 1 plus 1, 3 into 1 plus 2. It is 135. Therefore, I got the foot of the perpendicular. Now the problem is not over. I got the foot of the perpendicular as 135. But the question is, I have to find alpha, beta, gamma. How to get it? The coordinate of the midpoint is given by alpha plus 1 by 2, beta plus 6 by 2, gamma plus 3 by 2. You know that the coordinate of the midpoint is x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. Now we equate it with 135. Then when all of us know that when two coordinates are equal, then each coordinate, that is x coordinate equal to x coordinate, y coordinate is equal to y coordinate, z coordinate is equal to z coordinate. For alpha plus 1 by 2 is equal to 1, beta plus 6 by 2 is equal to 3, gamma plus 3 upon 2 is equal to 5. Now if you equate alpha 1, 0, beta 0 and gamma 7. Therefore, the coordinate of the image is 1, 0, 7. Now the question is not over. They have asked some more question now. Now I got the image as 107. What they want? The distance between the point P and Q they want. How to get it? Make use of the distance formula. Therefore, it is coming as root 52, which is nothing but 2 root 13. Now, they can ask you the equation of PQ also sometimes. Now, you know how to get it because you know the direction ratios and you know any point on that PQ. Now, you can write the equation of PQ also. These are all possible questions. Put out the perpendicular image, then the distance between the point and the image, and the equation of the line joining the point and the image. Now let us go to the next interesting idea, shortest distance between skew lines. Two lines in space which are neither parallel nor intersecting are called skew lines. They are all special lines. If L1 and L2 are two skew lines, then there is one and only one line perpendicular to each of the line. This is very, very important. Now you see, I am showing you two lines L1 and L2. They are neither parallel nor intersecting because they are in different planes. They are neither parallel nor intersecting. Now you are seeing that there is only one line which is perpendicular to both of them. That line is called the line of shortest distance. Now PQ is the shortest distance between the skew lines. In the exam, they will ask you, they will give you two skew lines and they will ask you to find the shortest distance. How to do it? Now we will go for the approach of vector method for finding the shortest distance because that is the easiest one you can think of. Therefore, first I will take A1 plus lambda B1. A2 plus mu B2 is the second straight line. Now, very simple, the shortest distance is B1 cross B2 dot, the dot product A2 minus A1 upon magnitude of B1 cross B2. We have taken modulus to tell you that the distance cannot be negative. Now, suppose how to do it? Very, very simple. Shortest distance between skew lines. Suppose if both the equations are given in vector form in the exam. Now, identify what is A1 and A2. What are A1, vector A1 and vector A2? They are the position vector of the point. They are called point vectors, which will be in the first place, A1 and A2. Then position vector of the point from both the lines. Now compute A2 minus A1 immediately and keep it ready. Then you identify B1 and B2. What are they? They are multiplied by lambda in the first equation, mu in the second equation. Anyway, that is mu there. Vector representing direction ratios of the both the lines. Now compute B1 cross B2. Then after that compute B1 cross B2 magnitude. You have to compute the magnitude. You know what is the magnitude of a vector? Square root of I component square plus j component square plus k component square. Then compute the dot product. Dot product also you know A1 A2 plus B1 B2 plus C1 C2. Then put it in the formula. Very simple. Identify A1 A2, identify B1 B2, find B1 cross B2, find A2 minus A1, find the magnitude of B1 cross B2, put it in the formula. Suppose if the equation are given in Cartesian form, what to do? Very simple. Convert them into standard form. Then you identify vector A1 and A2. What is vector A1? Same thing. It is x1i plus y1j plus z1k. A2 is x2a plus y2j plus z2k. They are all position vector of the points. Then once again A2 minus A1 compute. Then B1 cross B2 out identify. They are the numbers in the denominator after you have converted them into standard form. It will be A1i plus B1j plus C1k, A2i plus B2j plus C2k. Is okay. Now you compute B1 cross B2. Then compute magnitude, put it in the formula. Now let us go to a question now, very simply. Before we go for that, if the shortest distance between two given line is 0, then the two line will intersect. Therefore in the exam, they may ask you, find the shortest distance and hence find whether the lines intersect or not. If you get the shortest distance as some value other than 0, non-zero number, they don't intersect. And suppose in the exam they are asking you, find the shortest distance between parallel lines. What is the meaning of parallel lines? For the first line also it is lambda b, second line also it is mu b. Their direction ratios are equal. Only A1 and A2 will change. But shortest distance is A2 minus A1 compute cross B, which is the vector which is obtained from the direction ratios upon magnitude of B. But be careful in the exam. Shortest distance is between parallel also they can ask. Well, now go to question number 5 from 2008 and 2014 question paper. Find the shortest distance between the following pairs of lines. I have checked it. The lines are in standard form. Therefore, the points are 3, 5, 7 and minus 1, minus 1, minus 1. Identify it carefully. Now I have written A1. I have written A2. That's all very simple. 3, 5, 7. Therefore, 3i plus 5j plus 7k. Minus 1, minus 1, minus 1. For minus I minus j minus k. Now, therefore, the direction ratios of the lines are 1, minus 2, 1 and 7, minus 6, 1. For I can identify B1 and B2. 1 minus 2, 1, therefore I minus 2j plus k. 7 minus 6, 1, therefore 7i minus 6j plus k. Now I got everything now. I will go for computing. A2 minus A1, very simple. Subtract the components. You will get A2 minus A1. It is minus 4i minus 6j minus 8k. Keep it ready. B1 cross B2, all of you know, ijk in the first row. Then the component of ijk in the second row from B1. The component of B2 from the component of ijk from B2 in the second row. Third row. Come on, expand it. I into minus j into plus k into. Normal expansion of 3 cross 3 determinant. For I got B1 cross B2 also as 4i plus 6j plus 8k. Now we will find its magnitude. Square root of 4 square 16, 6 square 36, 8 square 64, therefore root 116. Now I am keeping everything ready now. What is the next one I have to find? I have to find the dot product. Dot product of B1 cross B2 dot A2 minus A1. Simply multiply the corresponding component, minus 4 into 4 plus minus 6 into 6 plus minus 8 into 8. Highly interesting, for you will get 116. For put it in the formula, 116 by root 116. Therefore, the answer is root 116. You can leave it as it is. Otherwise, you can write it as 29 into 4. Therefore, 2 root 29. Therefore, whenever any problem given in shortest distance, please go in that order. Identify A1, vector A1, vector A2, vector B1, vector B2. Compute vector A2 minus vector A1. Compute B1 cross B2. Find the magnitude of B1 cross B2. Find B1 cross B2 dot A2 minus A1. Put everything inside the formula. Well friends, success is dependent on efforts. All the best. Thank you.